Okay, we are going to pick a problem in economics. So let's pick one of these, 41 through 44. Who wants to pick? 44. Okay. Are we able to see in the back? Yes. Okay. So 44, we want to find the interest rate required for an investment of 5,000 to grow to 61,000 in 5 years if interest is compounded as follows. There are two options, annually and quarterly. Good? That's me. Now, add a part 0 when I do the problem. This will make sense. Or something before A. So initial part, simple interest. Let's add simple interest also. So we have a problem where initially you start with 5,000. Over some time period, it ends up being 6,100. 5 years go by during the time. The word here is compounded as follows. Anytime you use the word compound, it's no longer simple, right? What does this mean to you in English if you're compounding something?
Breaking down. Breaking down.
Breaking it down. In what way?
Smaller parts.
Smaller parts. Do you want to put it in context here? In a way, I can see it as
broken down. Interest is broken down.
okay. The interest is broken down. Great, but how does that relate to the compounding effect?
You combine them.
You combine them how?
Put them together.
Putting them together. Listen. Oh, good. Let's just say combine them, putting them together. To compound something would mean you're applying something to itself over and over and over again. Goes back to exponential. Isn't that what the definition is for an exponential function? 2 gets multiplied to 2, gets again multiplied to 2, and so on. So simple interest and compound interest, they're not the same. And we write that problem down. Yes. Good. Okay. I'm going to write also, so we don't worry. So you know the amount when you first start, 5,000, and after 5 years it becomes 6,100. The rate is not given to you. That's what we need to find. We find interest rate. The two options that they've given us for conditions, if it is compounded A, was it annually? Yes. I believe the next one was quarterly. Part 0. I'm just going to tack on simple interest. We like to keep things simple, hence simple interest. But this is not the way most businesses or banks operate. They go with compound interest. Okay, they gave us the formula. Interest is P times R times T. R is the rate, T is the term. What is P? Michaela, do you know? Very good. Principal. It is the amount that you start with. So principal rate and term. The result of the formula is simply interest. Good. I want you to read that problem carefully and tell me what P is. That's the principle. You think or you know, Rolf?
I mean, I think,
You think? Okay, Rolf says it is 5,000.
I think,
You think? Okay, do you agree? Yes. Okay, James seems to agree with Rolf, 5,000. Whatever you start with is principal, so 5,000, so that is P. The problem clearly states that we've got to find the rate, so we need to solve for R. Okay, so we don't know what that is. Do we have T?
5 years.
5 years, that is the term of interest, whatever. So I know P, I know T. Do I know I needed in this particular problem? 1100, I don't even see 1100 here. But you come up with that number.
subtract 6,100,
Very good.
5,000.
So subtract those two. Did we write this? If we assume simple interest, you started at $5,000 over time, 5 years go by, you end up at 6,100. Interest is simply whatever amount that you make in excess. How much did we make? $1,100. So time 0, you had 5,000. Sometime later, you get 1,100. So in that formula, principal 5,000, rate, time, 5 years, that amount is, should it be 6,100 or 1,100? No, 1,100. So the simple interest formula, it only gives you the amount of interest. It does not give you the final amount. So this is not the final amount, rather it's just interest by itself. So if you put it in the formula, what do we get? R to the
Why you get 1,100? Oh, you subtract.
yes, because it's only interest, not interest plus principal. Okay. So let's say you put $5,000 in the bank, yes, and say a certificate of deposit and some interest, 5 years go by, the money you put in, it's still there, agreed, and because of the interest, you're getting some in excess, and that amount is 1,100. So the original plus interest is 6,400, but here I just want to know what the interest amount is, so that is 1,100. What is the answer?
0.44.
0.044. Okay. 0.44, because that seems pretty high. In terms of a percent, what is that amount?
4.4%.
4.4%. Good. You know, we talk about mortgage rates, we talk about rate for loans when you buy a car, all that stuff. Do you believe those are simple interest scenarios? Credit card, do we have? No. You're lying to me. No one here has credit card? You do? Okay. If you use it properly, it's a great tool. Do you believe credit cards use simple interest? Never trust those banks, I'm telling you. If anything that you've got to learn as an adult, don't trust the bank. I should have paused the video, but that's okay. They know it's true also. Credit cards, mortgage lending, all of those are compounded interest. Formula is not as simple as what and that, right? But they follow the same logic. Which is why people say, don't keep piling on to your credit card, because if it is a simple scenario such as this, no big harm. But if rate is getting compounded and you keep on adding more charges to your card without paying at a good pace, you're going to go deep down into the rabbit hole. Yes. Okay. So before we end, are we clear with the simple interest rate scenario? Going to write the formula. Can I erase this? Compound interest. Same situation, but this is what the formula is going to look like. Standard notation is to use the letter A. We know what P is, we've discussed that. We know what R is, we actually found what R is in simple interest scenario. Michaela gave us what T is. The only letter that we do not know right now is M. But when Michaela was explaining the word compound, she gave an explanation. Would you like to explain again as to what that M is? M is a compound like oxygen or water. The amount or the number of times you compound the interest, how many times do you apply interest per term? So if you apply it once a year, if the term is in years, you apply it only once. What is the value of M? Go ahead. Yeah. One. Louder. What's your name? Cameron. Cameron says 1. If you apply the rate once a year, the value of M is 1. Let's say if you apply it quarterly, what is the value of M? Make it 4. We have 4 quarters. Lastly, the final amount here is principal plus interest. Do we see the difference between this formula and that one?
TM, is that part of the equation?
It is part of the equation. We'll just talk about it more. Do we see the difference between the two? Just interest here, principal plus interest. Before you come to class next time, let's see if we can solve this on your own If not, I'll do it.